Hello everyone. Let us start our today class. First of all, I am starting with my introduction. My name is Sumit Kumar. I am PMR Research Scholar at IIT Ahmedabad. I am taking the course of Geotechnical Engineering, in which we are studying the various aspects, basically the practical application of geotechnical engineering. And through this coursework, our aim is to learn the implementation of the concepts which we have gone through during our geotechnical engineering one class, or maybe the soil mechanics class, whichever the subject you have. Okay, so in this coursework, we have read the many concepts up to it, like the shear strength and different factors associated with shear strength, its importance, its significance, and its applications at several aspects, and how to calculate the shear strength with the help of different tests is also studied by us at different classes. Apart from that, the earth pressure theory and the bulkheads, anchor bulkheads, cantilever bulkheads, about those factors also we have studied and gone through some of the problems as well. In the previous class, we have started the slope stability. And today we are going to take those concepts forward up to an extent. So you get the better understanding about those concepts. And in the meanwhile, we will also solve some of very good problems associated with the slope stability. So that will give extra edge in your understanding. So in addition to that, I will try to add some points over here. The points like that this meeting is going to be recorded and get uploaded in a YouTube, and those links will be shared with you. So any one of you who are interested may visit over there and go through the video lectures. Apart from the content which I present over here is also shared with you through the Google Drive link by the NPTEL team, and those links are already with you. Okay, so now we are going to start our discussion. One more point, like if in a meeting due to any technical errors, if my call get disconnected, please we remain there in a meeting. I will rejoin and again start the meeting with over there. And this is the 14th. This is the um, uh, actually the 12th lecture of this series. So I have also planned to take one more class in the coming week on Wednesday from 3 to 5 only. So any one of you who are interested to join in can join, and we will go ahead with those concepts. Okay, I think so. Up to this, every point is clear. So let's start. Now we will begin our discussion from here onwards and take the concepts to move forward. Okay. So give me a minute before I will start. Okay, so I think so my slide is now visible clearly. So we will go ahead from here and take our discussions. Basically, I am trying to share my presentation, and due to some problems, it is not going to possible. That's why it's take 1 2 minute time. Okay, so no problem. Now we are studying the geotechnical engineering too, and we have discussed this aspect at several point of time that in this coursework we have planned to implement the concept which we have gone through earlier in our study to implement those concept in a practical application so that our understanding get developed on this course. Okay, so this is the course named Geotechnical Engineering 2 is taught by Professor D.N. Singh sir from IIT Bombay. In this coursework, we have studied the shear strength, earth pressures. Now we are going for slope stability, anchor bulkhead, and many more concepts we have gone across. Okay, and several practical examples you have also learned from different times to time. So now this is the actually the last lecture of the series in a real sense, but I have planned to take one more lecture on the coming Wednesday from 3 to 5 only. So those who are interested to join in, please join and they get benefited from there. Okay. So first of all, today topic is slope stability. So we will start with the basic understanding. We have also discussed this in the last lecture as well. So here I am taking those concepts little bit forward in order to give you the better understanding of the concepts and factual information related to the slope stability. Okay. So first of all, slope. Slope is a word came over here. So what do we understand by slope? Actually, you have seen in hilly regions or from day to day news articles, you have seen that somewhere landslide takes place. So the slopes are present over there. They are actually mostly the natural slopes are there, but some slopes are man-made as well. So the failure of those slopes leads to the instability, and we always want to keep the things very keen in order to make the slope stable. Because if slope failure takes place, it will lead to the damage of life of people as well as the infrastructure also get damaged. And so it has been found that there are many slope failures has been observed over the years. So how they are stable, how much they are stable, how much load they can sustain, what is the factor of safety over there. Those studies are the main concern when we are going through those concepts. Okay, so I think so up to this the basic understanding about the slope is clear. So now I will carry forward these concepts a little bit for your understanding. So first of all, the slope. Slope are actually the inclined surface that are found naturally or created by humans, as I have discussed earlier as well. So, the slopes are could be natural or man-made, but most of the slopes are natural. Slope stability is the ability of slope to resist the failure. Basically, whenever we are talking about stability or instability, so stability that concept that it will avoid its failure, and our main concern is also to avoid the failure of slope, because in any cases we doesn't want to slope to be get filled, because if slope get filled it will lead to the damage of infrastructure. It will also create the damage to the life of the people. So those things are the primary concerns of the civil engineers in order to avoid those types of accidents. Okay, so the concern related to the slope failure. So the what are the reasons due to which the slope failure could take place? So the talking about some of the primary reasons, the slope failure can occur when the forces driving instability exceed the force resisting instability. This is the basic concept. From starting, when we are studying the shear strength, we are talking about shear strength. We have talked about the parent body, deformed body. So over there also, we have interrelated those concepts that at the verge of failure, a critical section get formed, and from that section only the failure takes place. So, the slope failure can occur when the forces driving the instability exceeded the forces resisting the instability. And when this condition arrives, the failure of slope is clearly observed. And in any way, we want to avoid those circumstances. Now, talking about the geometry of slopes, the slopes could be formed at a different angle. It is not like somewhere the slope is too much steep. We in going through we will study the finite slope and infinite slope. So we need to be understanding need to have the understanding of the geometry of the slope. Otherwise, we could not able to differentiate between the different geometry like the finite and infinite slope. So the angle of slope and the height of the slope are the sum of the concern which need to be understood. The shape of slope can also affect the stability, and it is very much clear in your understanding that if the shape of the slope is too much steep or too much flat. What it mean by? If the slope is too much steep, it mostly the finite slope. But if the slope is mild or very mild, so it will be the infinite slope because we have observed specifically in the region where not too much evenness, there is a slope is there throughout the territory. So those understanding need to be developed, and it has been found over the years that the topography affect the slope when it gets filled, and its strength is one of the concern which we all aware about. Okay. No problem. So now, so talking about the soil and the rock property, the on slopes mostly found in the hilly region, the property of the soils over there is also one of the important factors. So the strength of the soil or rock, the type of soil or rock, and the moisture content of the soil or rock can all affect the stability in a way. Groundwater is also one of the concerns because we already know we have discussed from initials only that the groundwater is one of the factor which may affect the properties of the soil in some manner, which may affect the stability of soil in some manner, because due to groundwater the change in the effective stress at a specific cross section get affected to a larger extent, so its presence itself is a problem for the soil, and it has been already told and has been told at the several occasions that the water table is one of the biggest problem for the soil. Okay, now we will move forward. See, when we move forward, we will find that the some of the more factor like vegetation. We have seen that the stability get affected when the vegetations cover over there get deforested, or maybe some excavation takes place nearby places. So those activity concerned with human sometimes also lead to the failure of the slopes. Now, see one more points in initiating the same things is like the vegetation. If we are talking about the deforestation, which could lead to the instability and slope. So some positive points also there that what vegetation protect, because if its eradication from the specific location could create a problem, so it presence at a specific location is also one of the prime concern. Okay, see, so vegetation can help to stabilize the slope by providing the root reinforcement and reducing the erosion. Because the why the instability is slow? Because the erosion takes place throughout the slope, because that is the slope is sometimes steep or sometimes very concerned factor regarding the instability of slopes or the failure of slopes. Now, talking about the human activity, as I have added this point earlier as well, that the human activity such as the construction, excavation, and deforestation can all affect the slope stability. Landslides are the most common type of slope failure. It has been seen from time to time on the several occasions we have heard in the news and at various places that the slopes over here get failed due to the heavy rain or sometimes also in the seismic activity, the failure of slope has been observed. So, so those when we talk about due to weathering or due to seismic activity, the slope get filled. That is the natural process. But when we talk about the human activity could lead to, so that is the factor related to the deforestation, excavation, and one more factor could be there is like due to deforestation, the root which act as a binding force to reduce the erosion at a specific location get eradicated and the failure of slopes get started. Okay. Now, talking about the landslides have been mentioned that the landslides are the most common type of slope failure. So the prevention from landslides is very much necessary. So the stability of slope and up to how much forces it is stable at a specific angle need to be understood. Now, see, rock falls. Talking about the rock falls. Rock falls are the type of slope failure that occur when the individual rock or boulder fall from a slope. And it has been seen that the sometimes you see that the rock falls um, it takes place like the too much rock particles get fallen from the upper section of the hilly region lead to the damage. So those things need to be controlled or avoided in order to prevent the failure and reduce the damage of the property over there. Now, talking about the debris flow. Debris flow are the type of slope failure that can occur when a mixture of soil, rock, and water flow down a slope. So, this is one of the concern about the slope failure. Now, talking about the mud flow. Mud flow are the type of debris flow that is primarily composed of mud. So, this is also concerned with the topic. Now, see. The some of the methods which has been used to stability of the slope or the analysis of stability for slopes. So first, one of them is the limit equilibrium method. Talking about the limit equilibrium method are the most common type of slope stability analysis method. Apart from that, the basically in this case we try to find the limiting force and in at which the failures of the slope get takes place. And talking about the finite element method, the finite element method are the more sophisticated type of slope stability analysis. So in the finite element method, like the slope by W or the recent commercial softwares are there, which in which the slopes are get designed and then seen that by applying this much force, what type of failures get takes place. And one more point I want to add that in the finite element method, the slopes which has been taken under study are discretized into small sections, and those small sections are studied separately. The analysis has been run, and then we reach at the specific outcome regarding the same that up to this much forces the this is stable, and after which it lead to the failure. So, finite element analysis is one of the most promising techniques in present day world, and it has been used widely. It basically actually replicate the true sense of the slopes which are present there. Now, talking about the drainage, as it has been earlier mentioned as well that drainage is one of the problem. So, the drainage can help to improve the slope stability by reducing the amount of water in the slopes, because it has been understood, it will need to be understood that the drainage, if the drainage is sufficient, then the water which is the problem for the soil will not create the problem in a true extent and can reduce the damage at those specific locations. Now talking about the retaining wall. Retaining wall can help to support the slopes and prevent the failures. The buttress are the masses of the soil or the rock that are added to the base of the slope to provide the support, and it's sometimes also act as a support to reduce the chances of failure of slope. We have discussed about the vegetation, and from vegetation what do we mean? We from vegetation we have understood, or we came to the conclusion that the vegetation can damage, the removal of vegetation can disturb the slope in the downward direction and may also ultimately lead to the damage of the slopes, or the create the instability within the slopes, because the one of the prime concern which one should look into about the vegetation is like the deforestation is one of the primary reason, that is the human induced reason which lead to the failure of slopes. Now, see, we have discussed about the slope geometry, the shape, size, and the angle of slope is equally important uh, for our understanding, because if the soil geometry is not taken care of and understood, then it may lead to the problem related to those facts. Now, Now, talking about the groundwater, the slope geometry, soils and rock property that has been clearly mentioned in the previous slides, previous slide. But the understanding about the groundwater is one of the major concern, that the presence of groundwater could lead to the damage of the damage, not affect the effective stress parameter, and could lead to the problem associated with those locations. Talking about the vegetation, the vegetation growth reduce the chances of erosion in those regions and stabilize the slope in itself in a way. So the slope presence of slope is also one of the good factor which we understood. Now, talking about the human activity. As we have mentioned that due to deforestation, the primary it has been seen that due to deforestation is the one of the human activity which lead to the failure of slope, and deforestation and excavation are two of the factors which lead to those problems. Now the landslides, rock fields, debris flows and mud flows are clearly defined earlier. So I don't think I need to discuss these points again, because those have been discussed in detail. Now we move to limit equilibrium method. As we have talked about that the limit equilibrium method and the finite element method are the sum of the analysis method through which the stability of slope analysis takes place. So the limit equilibrium method and the finite element method are the two methods. The drainage conditions, retaining walls, buttress which support the uh, which support provide support at that section, vegetations, and how vegetation could help. So these points we have gone across from very elaborate way to develop our understanding. Now, we move to the stability of slopes. So over here we will check some of the other concerned practical examples which could give broader aspects to our understanding. Now talking about the stability of slopes. So the slope, first of all, slope definition, we understood very clearly that the slope is that section which is maybe finite or infinite that can be present specifically in the hilly area. The large sloping region could also be lead to the giving a balance in a way, but if the slope is not very large, if it is not infinite slope, finite slope, so over there the analysis takes place in the different concern. We have discussed about that. Going forward, we will discuss the methodology as well, that how to find the factor of safety if we want to achieve this one factor of safety, how much depth should be there. So those points we will discuss, or maybe some with the help of some questions we will reach to those objective concerns and can give a concluding remark regarding the same. Now, the types of slope we have understood earlier as well. The causage of failure of slope is maybe the natural or man-made. Talking about the natural causes, which include the failures of slope and due to the instability of slope, due to the seismic effect, or maybe sometime due to erosions or maybe due to heavy rainfall, which lead to the weakness of soil at those specific locations. Now, now moving forward, when we see the patterns associated with the flow failure, so the talking about those patterns, so the what pattern it followed during the failure of slope is one of the prime concern to develop our understanding. Talking about the aim of slope stability. So the primary aim is to give the safety to the people who are residing over there, or maybe using those locations for their day-to-day activity, or maybe due to the transportation aspects. So it's need to be clearly understood. So, see, it need to be clearly understood that the large economical damage as well as the damage of life of people, which lead to the serious concern or the serious problem, need to be eradicated. And so the primary aim is to reduce those losses. Talking about the factors, the type of factors of safety. So the factor of safety over here is a study in which one will clearly mention regarding the fact related to the failures, how the eradication of failures could be achieved. Now talking about the stability analysis in slope. So there is an infinite slope and finite slope. And infinite slope is of the larger length as compared to the finite slope. Finite slope in infinite slope, we take the analysis at the specific sections and then develop our result in finite slope. The slope is finite, so it doesn't mean that the finite slope is have a very less inclination or large inclination. This is not associated with those facts related to infinite slope and finite slope. So in finite slope, we are first of all going through the infinite slope in we develop our understanding regarding the same. Afterward, we will move to the finite slope. So in infinite slope, the factor of safety associated with the factor of safety associated for the different types of soil will be taken in our consideration. Now, see, there are two types of slope, infinite slope and finite slope. Now talk about the Taylor stability number, Sn equal to C by gamma HFOS. So we will discuss about that those factors as well. that what do we mean by Taylor stability number, how it could be used, and how we identify our problem and solve the problem associated with those concern point. Now, ultimately the method of preventing slope failure. Okay, there is a one more aspects which we not taken over here is the benefits. The benefits one can get with the slope failure. So the benefit we will achieve by stabilizing the slopes and trying to avoid its failure is like to reach at the outcome over there where the over there that the failures which lead to the large ecological change or the physical change and can lead to the damage of life as well as there is a huge economical loss takes place in that regard will be eliminated. So these are the some of the important benefits. Okay, I think so. Now we will again start with the definition and we will go one by one. Okay, so I think so my slide is visible, so give me a minute. Now, see, we will start with the definition. So, what definition suggests? Definition say it at the surface of water which one end or side is at higher level than another, a rising or the falling surface is a slope. Okay. And a slope can be defined as the inclined body between the ground and the air. An earth slope is inclined or unsupported part of a soil mass. So that is one of the important thing which we need to understand. So it is, from definition it is very much clear that a slope can be defined by the inclined body between the ground and the air. So that inclined body is actually the slope. Okay. Now, see, moving forward, when we see that the slope on the earth are of two types. There is one is natural slope, that slope exists in the hilly area, and another is of the slope of the type which has been constructed due to the human activity or which has been manually created those slopes. So those factors need to be understood. Talking about the man-made slopes, when we see the natural slopes over here, you can see the slopes which are present above the mountain region. So those slopes are the natural slope which has been existing over there from the long period of time. But when we talk about the slope which will created by human, that is of the concern. So the sides of cutting, the cutting and filling takes place. So the side of cutting is a man-made slope. The slope of the embankment constructed for the road, railway lines, canals, etc. are the man-made slopes. The slope of the earth dams constructed for the storing water is also a man-made slope. Now, now, when we move forward, we will define and get a solution and get a understanding of the infinite and finite slopes. There must be some difference between the infinite and finite slope. So those understanding we need to be developed. So we will identify those type of slope and can get associated with those type of slopes, because when we take the analysis on the infinite slope and when we want to take the analysis on the finite slope, the analysis takes place in a different way. The term infinite slope is used to designate a constant slope of infinite extent. Basically, that slope is going from one point to another point in a very long distance, and The long slope of the face of a mountain is one of the example of infinite slope. Now, talking about the finite slope. So the finite slopes are of the limited extent. The slope of the embankment and the earth dams are the example of finite slope because over there their length are not too much big. So it will be one of the prime lead to the prime understanding about the infinite and finite slopes. Now come to the next point. And what is that next point? That is the causes of failure of slopes. So some of the important causes considered first of all the gravitational force. Force due to seepage of water, erosion of the surface of slope due to flowing water, the sudden lowering of water adjacent to slope forces due to the earthquake are some of the reasons which lead to the failure of slopes. I think so. Up to this, every point is crystal clear for everyone. I think so. Okay, so give me a minute. I will take some water. Now, see, we have discussed the region behind the failure of slopes. So now we will move and see the pattern of slope failure. So over here, from the diagram, you can see that the rotational landslides could take place. The translational landslides could be there. Block side could be there, and the rock fall has also been presented. The topple, debris flow, debris avalanche, uh, and the earth flow are some of the things which has been seen over here. The Saturn pattern diagram. So it is showing the different patterns in which the failures of slopes actually takes place in the field. Now we will see the aim of slope stability. We have came across these pointers again and again in different language, so we get developed our understanding and could speak in very we speak, understand, and try to avoid the instability across the slope. So for this, the access the stability of slope under the short term, often during the construction and the long conditions need to be taken care of. To access the possibility of landslide, involving natural or existing engineering slope to analyze the landslides and understand the failure mechanism and the influence of the environmental factors. To enable the redesign of the field slopes and the planning and the design of the preventives and remedial measures were necessary to study the effect of seismic loading on slopes and embankment are some of the primary aims behind the study of stability analysis of slope. Now, now you see over here the causes of slope failure. The failure of slopes of a soil mass occur along a plane or the curved surface in a large mass of soil side with respect to the remaining mass. In other words, we can say that there is a downward and outward movement of soil mass in a case of slope failure. A slope failure occurs when the forces causing the failure are greater than the shearing resistance developed along the critical surface of failure. The factors leading to The slow failure is divided into two types: the factor which causes the increase in the shear strength and the factor which causes the decrease in the shear strength. Okay, no problem. So we will again go with the cause of slow failure. And so the failure of soil mass occur along a plane or a curved surface when large soil mass slide with respect to the remaining mass. In other words, we can say there is a downward and outward movement of soil mass. In case of slope failure, a slope failure occurs when the forces causing the failure are greater than the shearing. Slow failure can occur when the focus causing failure are greater than the shearing resistance. Shear strength developed along the critical plane. The factor leading to the slow failure is divided into two parts. The first is the factor which causes the increase in the shear strength, and the second one is the factor which causes the decrease in shear strength. Talking about the slope stability, so going over here, talking about the factor of safety, we will take a small 5 minute break, and afterward we will start our discussion going forward. So over here we are taking the 5 minute break. Hello, hello everyone. Please be remain in the meeting. There is a network issue going on over here due to which this meeting is little bit delayed. Not to worry, I will take the class accordingly. I am trying to join with my laptop, so please wait for some time. Uh, I'll be joining with my laptop in a meanwhile. Please be waited. Welcome back, everyone. There is a problem associated with network. That's why I am not able to visualize over there. Okay, so now the network problem has been sorted. So we will start from here. Okay, no problem. The 5 minute break we are taking every day, so that break is compensated. That break is not happening for me, but you guys have taken your break. So we will go from here. I think so my screen is visible now. Okay, my presentation is visible, I think so. Yes, it is visible. Okay, so I will start from here only, where we have left, and we will move forward accordingly. Slides is visible to the screen, so I will start from here and move forward in this regard. Over there, we will try to sort out all the concept. Basically, the main concern is that to present the concept to you, and if I am able to do so in how much remaining time, then there is no problem. And if it more time is required, I will take the time over here only. And apart from that, one more class is also there on the coming Wednesday, so not to worry regarding anything. Okay, so we are talking about the causes of slope to fail. So the failure of soil mass occurs along a plane or a curved surface when a large mass of soil slides with respect to the remaining mass. In other words, in other words, okay. In other words, we can say that there is a downward and outward movement of soil mass in case of slope failure. Okay. So when we came across those points, we understand that a slow failure occurs when the forces causing the failure are greater than the shearing resistance, that is the shear strength. Okay, I think so. Points are very much clear up to date. The network is a little bit. That's why I'm trying to set up those things forward and backward. Okay, no problem. Okay, so the failure of soil mass occurs along a plane or a curved surface when the large mass of soil slides with respect to the remaining mass. In other words, we can say that there is a downward and outward movement of soil mass in the case of a slope failure. A slope failure occurs when the forces causing the failure are greater than the shear resistance, that is the shear strength developed along the critical surface. And talking about the factors that lead to the slope failure is divided into two types. The factors which causes the increase in the shear strength and the factors which causes the decrease in the shear strength. Now, talking about the factors which contribute to the shear strength is like the strength which has been associated with the strength factor like vegetation. If the vegetation is there, that provides the reinforcement, rooting reinforcement in a way. So, it will help to reduce the chances of failure. But on the other hand, at the same point of time at that place, if some other factors like mm, some more points are there like intercepts or maybe confining requirements, so it will lead to the failure in one way or the other. Okay, so I think so. Up to this, every point is very much clear in everyone's mind. If any doubt is there, anyone can ask at any point of time. There is no issue in that. So we will look into the matter that we will look into the matter. So we are talking about the factors. One factor that contribute and other factor that basically that the one factor that lead to the increase and other factor that lead to decrease. So those are the vice versa of each other. When we are talking about the vice versa of each other, how everyone think that how those two concepts are vice versa of each other. So this is a very easy understanding that how those concepts could be the vice versa for one another. So let's see that how those two points are vice versa. So let me clarify it for your understanding. Like if the failure takes place, if the failure takes place due to the sudden, um, maybe sometimes you see any infrastructure project is going on, some excavation process has been followed, which may lead to the failure of soil at that section. But on the other hand, it has been also absorbed in a sloping ground. Sometimes there is a growth of vegetations has been implemented. Some afforestation takes place, which try to include the which try to tighten the soil over there, provide a mechanism to enhance the strength at those specific sections, may create a positive impact in a way. Okay. So now we will move to the next part. And what is that next part? The coming part is talking about the slope stability. From starting, we are talking about the slope stability. We started with a definition. Now we are concerned about the slope stability analysis, what we are trying to determine. So in slope stability analysis, we are trying to determine the factor of safety and what do we want with these factor of safety? Okay, there is again problem. There is, I think so. Again, network error takes place. Okay, so this is the problem associated with again and again network problem has been arises today. What is the reason behind this? I am not getting at this point of time, but let's see let's see that what we can do to sort out the problem associated with the network. So let me regain the network. In the meanwhile, I will try to rejoin the network so that I can explain the concepts over there. Okay, so it has been setting up. So I will join. I will try to rejoin. I think so. The network has been restored. Okay, network has been restored. So, am I clearly audible? So again, I need to share my presentation. So there is a problem of network today. I think so. Maybe many more people are consuming the internet services because there is a much awaited cricket match going on today between India and Pakistan. That's why the load on the telecom operators are too high. That's why it's lead to the network issue. Otherwise, from the last 11 weeks, we have gone through this course. So never network issue arising. But today it has been observed. So maybe that may be reason. Okay. I think many of you also enjoying that match. Okay. Let's see. See, we are talking about slope stability. So in slope stability analysis, we determine the factor of safety as the ratio of resisting force to the driving force. So factor of safety is calculated on that basis only, that how the resisting force and the acting force is going to act. So we will see those concerns over here. Okay, so whether my presentation is visible, I think so. It is not visible on the screen very clearly, but I will try to sort out. Okay, no problem. We are talking about the slope stability. So in the slope stability analysis, we determine the factor of safety as a ratio of resisting force to the driving force. The factor of safety is resisting force by driving force. There, theoretically, any slope with a factor of safety, when we talk about the theoretical consideration, so theoretically the any slope with a factor of safety less than 1 will fail, and any slope with a factor of safety greater than 1 will not. So when we are talking about the factor of safety, it has been very much clear in your mind that factor of safety is associated with, it is very much clear that the factor of safety is associated with the concern point over there, that how much resistance one can offer in order to, give me a minute again, there is some problem. Give me a minute before I will join again. A huge network problem it has been seen today. So I try to resolve, but it has been found very difficult at this point of time. No problem, not to worry, because I will stress that class. I will cover all the concept in any way. That's not the problem. That's not the big deal for me. So you need not to worry about the same. Network connection is little bit tricky today. I am losing the connection again and again. What's the reason behind this? I didn't get it, but this problem is there. So please be patient and wait for me to joining in back. A very unstable network. Okay, no problem. I think so. My connection get restored. So I have rejoined without a problem. Now my presentation is also visible. Yes or no? Yes, it is visible. Wait for a minute. Wait for a minute. Okay, the connection get restored. So I will again try to share my screen. This is very difficult to know because sharing my presentation will be going difficult again and again. Okay, I think so. Now everything is okay. So we will move forward from it. Okay. So I am talking about the slope stability. So in slope stability analysis, we determine the factor of safety as a ratio. I think so. I have taught this again earlier as well, but I don't know whether on that time the network has been there or not. So I will take this again just for the sake of better understanding of your knowledge. Okay, so theoretically, any slope with a factor of safety less than 1 will fail, and any slope with the factor of safety greater than 1 will not. So, the design focus on the soil parameters and geometry that will provide the maximum factor of safety. Okay, so over here we are talking about the designs that will be focused in our study. So sometimes the analysis of existing slope with is called a parametric study. In that study, we try to establish a factor of safety and perform an analysis that back calculates the strength of parameter, and over there by suggesting by calculating the factor of safety we try to reach at the outcome in which we suggest the solution of the problem. So the performance and analysis that back calculates the strength parameter, and the engineer will then determine his her confidence level as to whether or not the soil has that strength through experience, lab, and or the field data. Talking about the types of factor of safety. So the factor of safety with respect to the shear strength, talking about the factor of safety with respect to shear strength, so it is defined as the ratio of available shear strength to the mobilized shear strength, which has been represented as Fs equal to tau by tau m, where tau m is the mobilized shear strength and tau is the shear strength, and the available shear strength. The factor of safety with respect to cohesion is known to be Fc, and it is defined as a ratio of available cohesion to the mobilized cohesion, which has been denoted by the notation Fc is equal to C by Cm, where C is the available cohesion and Cm is the mobilized cohesion. Talking about the factor of safety with respect to the friction angle Fi, so it is again defined in the same term as the ratio of available friction to the mobilized friction, as F phi is equal to phi by phi m, where phi is the available friction and phi m is the mobilized friction. So we interrelate these terms in this way to provide a factor of safety at this specific location. Now we talk about the types of slope failure. So slope failure could be the and takes place in the different like slope failure, toe failure, and base failure. So in the failure you see at the in the last diagram the failure takes place from the base. So the soil at the toe and at the face is stronger as compared to soil at the base. That's why the failure takes place in this case from the base only. Similarly, when we take the second last picture in which the toe failure is represented, so in this case, the soil at the base and soil at the face are stronger as compared to the soil at the toe. That's why failure takes place from the toe. And this failure is said to be two failure. Similarly, the slope failure, that is the face failure, has been represented in the same regard. In that case, the strength of soil will be different at different positions, which lead to those failures. Now, talk about some of the assumptions which has been made in the analysis. So the talking about the assumptions, the stress system is assumed to be two-dimensional. Stress in three direction are taken as zero. Third direction is taken as zero because we are running the analysis. You are assuming the third dimension, but you are taking the third dimension as zero in order to make our understanding and calculation easy as compared to what it to be. So we already know now when we talk about the shear strength, we have understood during our understanding of the shear strength, we used to do the similar applications. On that regards, we are performing our analysis and we try to convert the 3D problem into 2D problem for the better analytical calculation for the better calculation result. So we could reach at the outcome and it would be generalized in the more general form because if the equation developed into 3D, it will be little bit more tricky and to solve as well at the same point of time. So these factors has been considered. Now it is assumed the Coulomb equation is used for determining the shear strength as S equal to C plus sigma tan phi. Now, it is assumed that the seepage conditions and the water level are known and the pore water pressure can be estimated. So, the shear strength of all the points are enough to mobilize all available shear strength. Okay, I think so. No problem with that. So, moving ahead, the stability analysis, talking about the stability analysis of infinite soil, infinite slopes in the different type of soil. So first of all, talking about the cohesionless soil. So for the dry state, the factor of safety of the infinite slope for the dry state may be written as Fs is equal to tan phi by tan I. Similarly, for the submerged state, the factor of safety of the infinite slope has been shown as the okay. I think so. I am audible very much clearly. So let me see from my other mobile whether I am audible or not. Then I will aim to the main factor. But okay, I think so. I am audible. So I will go ahead with that. That the for the submerged state, the factor of safety of the infinite slope for the submerged state has been given as Fs is equal to tan phi by tan I. So I am talking about the submerged state. So in submerged state, the factor of safety of the infinite slope for the submerged state is given by F is equal to tan pi by tan I. As it has been earlier also shown that in the when we are using the cohesion and mobilized cohesion in that way also we are taking the factor of safety in a similar manner, and in that case in this case also we are analyzing the factor in a same aspect. So, talking about the steady seepage along the slope. So, the factor of safety of the infinite slope for the steady seepage along the slope may be written as Fs is equal to gamma dash into tan phi by gamma sat into tan phi I. So, in this case, you also know that gamma dash by gamma sat is approximately 1 by 2. So, sometime 1 by 2 tan phi by tan I is also one of the aspects which has been stated in the several textbooks or maybe several conceptual notes when you go across. So that's not a problem because it is almost because we are considering 9.81, then it's not half, but in some cases or the other it is approximately half value. So Those considerations are taken care of by at different locations at different places. Now, talking about, as we have discussed for the cohesionless soil, when we're talking about the cohesive soil, so Fs has been modified and it become Fs is equal to C by gamma cos I sin I into H, and the factor of safety when we calculate for the infinite slope in the summary condition for the purely cohesive soil, it is given as C by gamma dash into cos I sin I into H. Similarly, moving to the steady seepage along the slope, the factor of safety for the infinite slope when the steady seepage takes place. So it by C by gamma set, because the steady seepage takes place along, so that it is fully saturated state. So C by gamma set into cos I sin I into H. I think so. Up to this, there will be no confusion. Now, talking about the stability analysis for infinite slope in the dry state, so the factor of safety of the infinite slope for the dry state may be written as Fs equal to C plus gamma h cos square I into tan phi by gamma into cos I into sin I into h. So we will go in the same manner. Okay, give me a minute. Okay. So for the submerged state, the factor of safety will be given as represented here, because for the submerged state, it gamma h term also come in the consideration, so it becomes C plus gamma dash h cos square I into tan phi by gamma dash cos square cos I sin I into H. Similarly, for the steady state seepage along the slope, the term changes to the factor of safety of the inclined slope for the steady seepage along the slope may be written as Fs equal to C plus gamma dash h cos square I tan phi by gamma set into cos I sin I into h. So this has been understanding part. When we go for the question, the applications has been used, and over there I could explain in a far better way than this what I am discussing over here. Now we talk about the stability analysis for the finite slope. So in the finite slopes, some of the important method which has been implemented is the wedge failure method, friction circle method, Swedish circle method, and for the like method of slices, and after that the analysis of purely cohesive soil as phi equal to 0 and analysis of C5 soil both takes place under the Swedish circle method. So we will go one by one. First of all, see the wedge failure phenomenon or the wedge failure method. So if a wedge failure occurs when the soil deposit has a specific plane of thickness, the stratified deposits generally fail along the interface. The following figure show a soil mass resting on the inclined layer of impermeable soil. There is a tendency of upper mass to slide downward along the plane. The contact AB has been represented over here. So here we can see the soil mass is above and the impermeable soil layer is there, and how the angle has been made. Discussing this, the force trying to cause the sliding is tangential component of the weight W along the plane of contact, that is T equal to W sine alpha, where alpha is the angle between the plane AB mixed with the horizontal, and the force tending to resist the sliding depend upon the cohesion C, and the frictional force is given by S equal to CL plus W cos W cos alpha into tan phi, where L is the length of the failure surface and FOS is given by F equal to C into L plus W into cos alpha into tan phi by W sin alpha. For the talking about the friction circle method, the friction circle method is based on the fact that the resultant reaction between the 2 points of soil mass into which the trial circle divides the slope will be tangential to the concentric similar circle of radius r sine phi. This is the also one of the question which has been asked here one times in many times in the some of the reputed examinations, that is r sine phi the radius of the friction circle method. Since the oblique Kt of the resultant at the failure is the angle of internal friction phi. This is of course implies the assumption that the friction is mobilized in full. Talking about the smaller circle is called to be the friction circle or the phi circle, and the focus acting on the sliding wedge are the weight W of the wedge of the soil and the reaction R due to the frictional resistance, and the cohesive force Cm is the mobilized cohesion of the slip circle. Talking about the graphical representation which has been implemented over here, where we can see that the question has been asked that what is the radius of friction circle method, so that will be nothing but r sine phi. And similarly we represent the concept of the friction circle, and the force which is acting on the sliding wedge has also been shown. There is a question also came there, so we will look into that what are the questions over there. Okay. Okay. So we will go forward, move forward. So moving forward, when we see the friction circle method, the following procedure is adopted for finding the factor of safety with the friction circle method. Considering in the slope as shown in the figure, the crest of his slope and toe of his slope has been shown as respectively point B and A. Now draw a tri-slip surface as arc AC passing through the two O as the center and R as the radius as represented over here. And when we go with that, we see that the radius r of a circle and the center has been represented. The theta is the angle, the slope has been shown, the toe and crest has been represented respectively as point A and B, and the tri-slip circle surface has been shown. Now find the centroid of the sliding soil mass ABCA and calculate the weight W, and accordingly we will move forward to find the value of the factor of safety by drawing the first of all we draw the first triangle where W has been represented, C has been shown, and the P has been represented. Where the trial slip surface wedge has been shown as ABC A, and the angle theta has been shown, and as we know L is equal to R theta, so the length of the arc is L is equal to R theta, so C plus L R theta by W tan beta, that is the actual equations. With the help of that we are going to solve. Moving forward, when we move to the step 5, we use the cohesive force acting along the element opposite to the sliding soil surface Cm into delta L. Now the total cohesive force along the arc AC form a force polygon. Also the closing side of AC of a polygon represent the magnitude and direction of resultant cohesive forces. Now you see, similarly solving these, ultimately we find that the mobilization of frictional resistance, let P be the soil reaction opposite to the sliding soil mass as shown in the figure. Reaction due to the frictional resistance P is inclined at an angle theta phi of to the normal at the point of the friction as shown. So by knowing the magnitude and direction of W and the direction and the line of action of the other forces, the force triangle can be completed, and measuring the magnitude of C and the factor of safety. can be computed as shown. So we earlier as also know we define the factor of safety. So here the mobilized cohesion change it to Cm is equal to C by Lc, and factor of safety with respect to cohesion is given by Fc is equal to Fc is equal to C by Cm. The minimum factor of safety can be obtained by locating the critical slip surface, and accordingly the solution could be stated. So this thing is crystal clear in everyone mind, I think so. If there will be a doubt, uh, I will rectify with the questions when it's we deal with the question. Now talk about the Swedish circle method. So the Swedish circle method in itself, Swedish circle method, talking about the Swedish circle method. So this method is developed by the Swedish engineers, assuming that the failure surface, assuming that the failure surface to be the arc of a circle, and there is two cases has been taken as earlier also mentioned, the analysis of pure clay where the phi is equal to 0, and the analysis of C5 soil in order to reach at the finding. See, the analysis of the purely cohesive soil over here, you see that the slip surface has been represented, AB where W has been weight has been represented, the eccentricity E has been maintained, and the arc length, as I already suggested, as it acts as the L equal to R theta, so the R is the radius, so L into C, okay, so here L equal to R theta has been also shown, and the total stress analysis of purely cohesive soil diagrammatically has been represented. Now, in this method, the number of trial slip circle are considered and the factor of safety for each is worked out. The circle corresponding to the minimum factor of safety is called the critical slip circle, and let AD be a trial slip circle, with R as the radius, O as the center of rotation, W be the weight of the wedge ABDA acting through the centroid, driving moment will be W into E, and let Cu be the unit cohesion and L be the length of the slip's arc. AD has been represented as 2 pi R into delta by 360. Here you will see that in the shear resistance developed, shear resistance developed along the slip circle will be equal to Cu into L. So the we are talking about the fact over here as Cu into L, as the slip surface will be equal to the shear resistance developed along the slip surface will be Cu into L, which act at the radial distance R from O. The resisting moment Cu into L into R, and F is equal to M R by MD, that has been actually Cu into L into R by W into E. Let Cm is equal to mobilized shear resistance necessary to keep the equilibrium, and now the W into D is equal to Cm into L into R. Therefore, Cm is equal to W into E by L dash into R and F is equal to Cu by Cm, so equal to Cu into L dash into R by W into E. Ultimately, our result has been found. So, the analysis of cohesive friction circle in order to test the stability of slope of the cohesive friction soil C5 soil. A trial slip circle is drawn and the material above the assumed slip circle is divided into the convenient number of vertical strips or slices as shown in figure. The forces between the slices are neglected and each slice is assumed to act independently as a column of soil of unit thickness and the width b. So over here we can see the schematic diagram. Each section has been represented, their thickness has been represented, their width diagram has been also shown. Now, the weight W of each slice is assumed to be at its center. It has been assumed, not actually acting, has been stated, but it has been assumed that it will be acting at the center. Okay. And if the weight of each slice is resolved into the normal and the tangential component T, the normal component will pass through the center of rotation O and hence do not cause any driving moment on the slice. However, the tangential component T causes a driving moment Md equal to T into R. Now we come to the conclusion in this section that where R is the radius of the slip circle and the tangential component of the few slices, the base may cause the resisting moment in the case of T is considered negative. Talking about the C is the unit cohesion and delta L is the curved length of each slices. Then the resulting force from the Coulomb equation has been given as C into delta L plus N tan phi. Now with the number of tri slip circle are chosen and the factor of safety of each computed, so the slip circle which give the minimum factor of safety is the critical slip circle. For the entire slip surface AB, we have the driving moment MD as R into summation of T and the resisting moment MR as R into C into summation of delta L plus tan phi into summation of N, where summation of T is the algebraic sum of tangential component of weights of the slices and summation of N is algebraic sum of normal component of the weight of the slices, where the summation of L as the length of the slip circle, which has been given as 2 pi r into delta by 360. So the factor of safety found to be mr by md means the resisting moment by driving moment. So our solution is going to be C into L plus tan phi into summation of N upon summation of T. With this regard, we reach at the outcome and propose a factor of safety. Talking about the method of calculating of summation of n and summation of t, so there are the method 1 in which the value of w, summation of n and summation of t may be found by tabulating the values for all the slices as indicated given here, in which first of all slice number has been put in the first column. Sorry, the area has been mentioned in the second column and similarly the weight accordingly. After that, the normal component and tangential component has been computed, after which the use of equation has been done in order to reach at the result. Now, talking about the second method suggests the summation of n and summation of t may also be obtained graphically. So there is a question in your mind, how graphically? So the vertical line drawn through the center of gravity of the slice and intersecting the top and the bottom surface of the slice may be assumed to represent the weight of the slice. This may be resolved graphically into the normal and tangential components. These components for all the slices are plotted separately as ordinates on the two horizontal baselines. The plotted points talking about the plotted points over here. So this may be resolved graphically. How? Into the normal and graphic tangential component. The component for all the slices are plotted separately as the ordinates on the two horizontal baseline. The plotted points are joined by the smooth curve as shown in the figure coming up, and they are called the N curve and the T curve respectively. So the area under these curves represent the summation of n and summation of t. The area under these curves are measured by the planimeter and multiplied by the unit weight of the soil to obtain the summation of n and summation of t respectively. And after that, we put in the main equation in order to find the solution of the problem. Talking about method 3, in the method 3, a simplified triangular rectangular plot method has been suggested by Singh and A62 to determine the summation of n and summation of t. In this method, the end ordinate of each slice is assumed to represent a as a weight of slice and is resolved into the normal and tangential component. So over here we see that the N1, N2, N3, N4, and so on, and the T1, T2, T3 has been represented, after which our calculation has been made to find out the summation of N and summation of T. Now talk about the Taylor stability number. We have studied about this word very early during this presentation. So the Taylor stability number. So if the slope angle I and the height of embankment be h, the effective unit weight of a material is gamma. So the angle of internal friction phi and the unit cohesion c are known. So the factor of safety may be determined with this interrelation. Taylor in 1937 conceived the idea of analyzing the stability of a large number of slopes through a wide range of slope angle and the angle of internal friction, and then representing the result by the abstract number which he called stability number. This number is designated as Sn, and Sn has been given as C by Fc into gamma h, where Fc is the factor of safety. So Sn and in other words, C by Fc has been mentioned as mobilized cohesion because we already know C by Cm as the fact one of the Fc value factor of safety due to cohesion. Moving ahead, when we see the Taylor stability number for phi equal to 0 case Taylor, they have also plotted some graphs, and with the help of this graph also one can reach at the specific outcomes. Okay. Now method of preventing the slope failure. This is talking about the method through which the slope failure could be prevented. Is one is the vibro station, another one is provision of beam berm at toe, third one is the vegetation cover. It is the very essential requirement and must require in order to also reduce the chances of reduction in the carbon footprint in one way or the other. Provision of seed pile is one of the another factor. Moving ahead, when we now we move to the questions, some of the small questions we will take in 5 minute time, 5 to 10 minute time. Then we will wind up our session. Over this very one mark question like MCQ questions will be there. So we will take the question, answer the those questions. So afterward we will move ahead. Okay, so meeting time is also coming to the end, but there will be no problem. I will take 5 to 10 minutes, 5 minutes at least, and these questions, small problems. Afterward, we will wind up our today's. Okay. So first of all, start with the questions. The first question over here is about Which of the following factor does not significantly affect the slope stability? Whether the slope angle, weathering, soil type, or altitude. So this is a simple question. Anyone say that the slope angle have not effect on slope stability? Wrong. Exactly wrong. So whether weathering doesn't have effect. Weathering has effect. Basically, it is the natural factor which affect the uh, fact which affect the slope stability. The soil type is one of the major concern because for the infinite soil, when we have developed our interrelation, we came to know that for the soil, the infinite slopes, when we take the cohesive soil, cohesionless soil, C5 soil, interrelation get changed. So the altitude option number D will be going to be our correct answer. So it is also mentioned over here. So option D is going to be our correct answer. Now, see, the second problem has been asked over here. What type of slope failure is characterized by a rapid downward movement of mass of soil or rock? So the question need to be read again. So we will read it. What type of slope failure is characterized by a rapid downward movement of mass of soil or rock? So the options are first one is slump, second one is creep, third one is slide, and fourth one is flow. So answer for this problem is going to be option number C, that is slide. The type of slope failure characterized by a rapid downward movement of mass of soil or rock is said to be slide. So option C is going to be our correct answer. Okay. So this is a small problem. Now we move to the next problem. The next problem is stating which of the following is not a common cause of slope instability. Talking about the common cause, it is not saying only cause. So their options are heavy rainfalls. One can say this is a common cause. This is not a common cause, but we will read all the options. Afterward, we will reach at the specific outcome that what could be the not a common cause of sloping stability. So the option number A is heavy rainfall. Option number B is vegetation cover. Option number C is the human activity. Option number D is seismic activity. So I think so you have understood your answer, and answer is going to be option number B, the vegetation cover. Yes, vegetation cover. So not a common cause of slope instability. So vegetation cover is not a common cause of slope instability. Okay. Okay. Now we will move to our next question. The next question asked over here is the what method is the commonly used for slope stability analysis in the geotechnical engineering? First one is weather forecasting, second is limit equilibrium analysis, third is the magnetic resonance imaging, fourth one is the traffic simulation. So this is question is very easy. So the answer for this problem has been going to be option number B, that is the limit equilibrium analysis. Because earlier also we have studied the liquid limit equilibrium analysis, finite element analysis. So over here the method commonly used is the limit equilibrium analysis because the finite element analysis is the different aspect. Over there the whole section are discretized into small section in order to perform the proper analysis terms. Now the next problem over here, that which type of slope stabilization method involve the use of the structural barriers to resist the pressure of the soil behind them? So the options are drainage system, soil nailing, retaining wall, grouting. So anyone can state its answer very easily, but for the sake of convenience, I will again read a question for the better understanding of question to state the solution for this question. So the question is which type of slope stabilization method involves the use of structural barriers to resist the pressure of the soil behind them? So the whether the drainage system, soil nailing, retaining wall, or grouting. So the answer for this question is going to be option number C, retaining wall. This has been very much clear for the question one. Now talking about the next question, which has been stated that which of the following factor can trigger the slope failure by increasing the pore water pressure? So the option number A is vegetation growth, second is reduced rainfall, third one is seismic activity, and fourth one is temperature fluctuation. So I think so it will be very much clear in your mind. The correct answer for this is the seismic activity because it will trigger the slope failure due to increase in the pore water pressure because under the dynamic condition the pore water pressure get developed. The concept of liquefaction in the dynamic loading will be very much clear in your mind. Okay, clear? I think so. See, now we are talking about our next factor. And what is the next factor we are talking about? We are talking about the next problem. So next problem over here is what is the primary reason for performing the geotechnical investigation in the slope stability analysis? The options are to increase the project's cost. That's I don't think so. To meet the regulatory requirement, delay the project timelines or to access the soil and rock property. So the option number D to access the soil and rock property will be the primary reason for performing the geotechnical investigation in the slope stability analysis. Moving ahead for the next problem which has been asked, I will end up the section by taking the 20 question. We are at it. At the question number 20, we will end our today's session. So not to worry because I have lost some time in mid between, so that's why I try to compensate with this time. It is already going to 5:10, so I will take 2 to 3 minutes, 5 minutes maximum, and wind up the session. So the question asked over here that which of the following slope stability method involves reinforcing the soil with grouted elements? So option is terracing, second is Gabon wall, third is soil nailing, and fourth is rock bolting. So clear from the options only. Option number C is going to be our correct answer. The background also say the nail, so you may pick up the options from there, but that's not the case. That due to that reason, that option has this slide has been taken. So the soil nailing for slope stabilization method involving the reinforcing. Okay, I think so. Everyone is okay with that. Okay, okay, okay. No problem. So we will move ahead for the next problem. Next problem say which type of slope failure involves the gradual downslope movement of soil or rock. Oh, we have already covered this. I think so. The answer for this problem is already known to you. That is option number C. Correct. Which type of slope failure involves a gradual down slope? Gradual. When we talk the steep slope, the fast movement. So over there, what is the option? You already know. Now see the next question. Now I will go a little faster with because maybe session get closed automatically. So that's not the case I want. So what is the recommended approaches for preventing the slope instability due to the heavy rainfall? So the options are increasing the slope angle, implementing the proper drainage system, removing all vegetation, adding more soil to the slope. So the option number uh, B is going to be our correct answer. That is implementing the proper drainage system in order to prevent the slope instability during the heavy rain. talking about which software is commonly used for slope stability analysis. So we already know the Microsoft Word is not that software which will provide us the slope stability analysis. MATLAB could be used at some extent, but it is not the primarily. So the slope by W is the correct answer. Option number C. Okay. Now the question is, what is the primary purpose of slope stability analysis? So the options are to increase the construction cost, no. To delay the project timeline, no. To ensure the safety of structures, to reduce the complexity. Okay, give me a minute. In the meanwhile, please think of the solution of this problem. Okay, so have you think of the solution? If no, I will give. And option number C. To ensure the safety of structure, to reduce the complexity of engineers in projects. Now moving to the next problem. The next problem states that what is the primary function of a retaining wall in slope stabilization? To increase the water flow, to promote erosion, to resist soil pressure, to amplify seismic activity. So the correct answer is going to be option number C, to resist soil pressure. Now move to the next. Next one is asking about which type of slope failure involves the sudden movement of a mass of soil or the rock along a well-defined surface. So whether it is a creep, flow, fall or slide. So option number D is going to be our correct answer. That is slide. So the next problem is which of the following is not a factor affecting slope stability? So rock type, it is affecting human activity also, the vegetation cover, atmospheric pressure. Okay, the answer is already represented. That is option number D, atmospheric pressure is our correct answer. The next question is what type of slope stabilization method involve the use of the plant roots to reinforcing soil, grouting, soil nailing, bioengineering, rock bolting. So the bioengineering is going to be our correct answer. Now the next question is what is the primary cause of slope instability due to human activity? Option number A is vegetation growth, B soil erosion, C is excavation, or the atmospheric pressure changes. So the option number C is going to be our correct answer, that is the excavation. I already discussed at several occasions talking about the excavation, deforestation, are some of the human induced forces which lead to the damage of the slopes over there. Okay, I think so. Things are very much clear. Now we will move to our next problem. And next problem states that okay, no problem. So the next problem asks that what is the primary cause of slope instability due to a okay, excavation. This problem has been taken. Now we move to our next problem, which has been asking about which of the following is not a type of slope failure: flows, slumps, creeps, landslides. So it is not a failure. So the option number C is the correct answer. That is creep. Is the answer of this question. Now, what type of slope failure involves the movement of unconsolidated material as a fluid? The option is slump, flow, creep, and fall. So the correct answer is going to be option number B, that is flow, because it's flow like a fluid. Option number B is correct answer. So we come to our last problem for the day, and the problem stating over here is asking about the what is the recommended approach for preventing the slope instability due to seismic activity? Option number A is increasing the slope angle. Option number B is decreasing the water flow. Option number C is implementing the soil laying, and option number D is removing the vegetation cover. So I think so. The option number see that implementing the soil nailing is the correct answer of this question solution for this problem. Okay, so with this, I will wind up the session for today, and I will take one more session in this coursework only on the coming Wednesday. So you can join in over there from 3 to 5. In a meanwhile, please take the understanding of the coursework to get the better idea of the subject. One more point I will try to add that in mid between today little bit network problem arises over there. So at some point of time, but I think so in recordings all contents will be there. So not to worry about that, and I will try to revisit those concepts which I have discussed during that time. But I think so all the concepts are already recorded. So when it uploaded, you can see the concept and you can cover the concept very well. With this, I will wind up the session. Wish you all the best for the exam which will be going to held with this subject. And for the final session, we will meet on Wednesday. Those who are available on that time can join me in. Okay, thank you everyone for joining here. With this, I will end up the today's session. Thank you very much.